So basically, this is isolated footings. The following figure below will help you to understand the effect of ground pressure on an isolated footing. So you have your column pressure, and then you have your compression area, which is basically when you have a ruler, it's compressing. So there's a force in the top section pushing down, and then there's a force at the bottom that's stretching the concrete. So that's the tension area. So always your bottom part is tension, your top part is compression. Tension area, ground pressure. So the ground pressure is pushing up, and then you have your column load that's pushing down, and that's what's causing the upwards force on the sides. So reinforcement will be popped up at the sides. So usually you have your reinforcement at your sides popping up. So they just say that it's bending upwards. And the reason for that is the following. It is a good idea to bop or bend up the reinforcement at the sides to prevent layer cracking in the concrete. As you can see, tension is caused in the, so that's a reason to prevent layer cracking in the concrete. That's why you bend it up on the sides. As you can see, tension is caused in the underside of the base. So reinforcement is needed in the bottom. So tension is caused in the underside. That's why we use reinforcement at the bottom, because concrete is weak in tension, strong in compression. There they stated. So they say, so reinforcement is needed in the bottom. Concrete is weak in tension and strong in compression, so we don't need to. It's actually add. So we don't need to add steel in the top. In the top, tension is only experienced in the bottom of the concrete, therefore causing the structure to be brittle at the bottom. So it's basically causing, what they mean with brutality is usually when concrete starts cracking. It usually cracks at the bottom where it's in tension for an isolated footing. It is also good practice to use the same dimensions for the side cover as for the underside. And what I mean with that is, the correct way is if you have 50 millimeters for your under, for your from here to here, and 50 millimeters from here to here, your concrete cover. But it's wrong to have, like, for example, 30 millimeters at the bottom and 50 millimeters on your side. It's either 30-30 or 50-50, or whatever the cover is at the sides. It should be the same at the bottom. Starter bars, as described in the previous unit, are provided for the column and need to be long enough to provide sufficient compression lab above the kicker level. So usually someone asks me what's the difference between the lab length and bond length. So lapping is when you have two steel sections lapping with each other, and bond length is when your concrete bonds with your steel. Because usually you get a table. I want to see if I can't get it quickly, where you have to do calculations based on your bond length and your lab length, and then you have to decide between compression, tension. So usually it looks like this. So if your minimum bond and lab length for fully stressed bars, so it's minimum bond length and then minimum lab length. So bond length is usually when concrete bonds with your steel, and lab length is usually when two steel pieces lap with each other. That's the difference between bond and lab. Because someone asked me once, what's the difference between bond and lab? Where do you use bond length? Where do you use lab length? Now you only have to decide between compression and tension. And if it's a high yield deformed steel, and usually that's 450 MPa, or plain round mild steel, and that's 250 MPa. and that will determine which section you're going to use, the top section or the bottom section. So that's the difference between lap and bond length. So in this course you are not expected to be able to design an isolated footing, so all the necessary information will be given to you. Okay, that's just explaining what we'll cover in this book, so I don't actually need to read further, but basically it stops at the starter bars, which is coming from your footing going into your column. Starter bars, as described in the previous unit, are provided for the columns and need to be long enough to provide sufficient compression lap above the kicker level. So yeah, and it's always in compression, your starter bars, because the force that's applied onto your footing basically coming through your column is in compression. That's why it's a compression lap. And that's it for that section of doing isolated footing reinforcement. That's just a bit of theory for how to design isolated footings or to do steel.